Hello, Algebra 2 class. Alright, for this video I'm going to continue section 3 of chapter 6 on the logarithmic function. And we're going to talk about a couple things. The first thing we're going to talk about is the one-to-one property. The one-to-one property states that if you have base to an exponent equal to the same base to a different exponent, then the exponents are equal. So the key about this is, well, you can see it's equal. We have some number to some number, raised to the power of a number. It has to be the same base for both of these, okay? And if the base is the same, then the exponents must be equal. So I'm going to do an example of this. Hopefully it makes a little more sense if I do an example. And the goal of this type of a problem is, what we want to do is we want to solve, we want to get like bases. We want to get the same base on each side. Once we have the same base on each side of the equation, we can then set the exponents equal to each other. We can just look at what this exponent is and set it equal to whatever this exponent is. So here we have a logarithmic function. V is equal to log base 125 of 5. Okay, the first step, so I'm right here now, is I'm going to rewrite this in exponential form. That's what we were doing in the last section. So I'm going to take my base, 125, raising that to the V power of V, and I'm setting that equal to 5. Now this is what I'm talking about. We want to make these bases the same base. We want to have like bases. So what I want to do is I have a base of 5 over here. I want to make this base, either make this base 5 or make this base 125. In order to make the base 5, I'm going to have to rewrite this. And I'm going to have to write it, so it's probably be easier to make, first of all, it's probably be easier to make this a base 5 than to make this a base of 125. And in order to do that, I'm going to have to rewrite this as a base to a power. Well, 5, where's my graphic calculator at? 5 to the third power is 125. Okay, so 5 to the third power is 125. So I can change the 125 to a base 5 by changing it to 5 to the third power. Okay? If you're not sure what to do, we want to get like bases here. Well, if I want to have a base of 5, you can just go through the options. If you can't tell off the bat, like intuition, some people might be able to see this by intuition. They have enough experience. But if you're like, oh, I don't know how to do that, well, I can just try things. Okay, it's not 5 to the second power. It's not 5 to the third power. Well, it is 5 to the third. There we go. So I can just go down through and guess and check until I get something to get the same base on both sides. I hope that is making sense. So what I want to do then is, here's an important fact though. Because 125 was raised to the V power, we're going to have 5 raised to the third power raised to the V power in parentheses. And going back to the beginning of the year and going back to previous math classes, when you have a base to a power, you multiply these two powers together. Okay? So this is a product. You can rewrite this as 5 to the 3 times V. Okay? Properties of exponents. Base to A, like if you have base B to the A to the B. Let me type this up. I can't write, unfortunately, but I can type stuff up. I can't write in real time. So if I have base B, this is just a property of exponents, raised to the, I can't remember what values. Let me use X, okay? And I'm going to take that, I'm going to raise it to the Y. Oops. isn't raising to the y. Sorry. Something happened weird. Oh, I see. Okay. My parenthesis got put inside the base. Okay. Actually, let me make this bigger. Sorry, bear with me. Make it a little bigger so it's easier to see. It's probably plenty big. So this is the property, and I don't remember exactly what variables I used at the beginning of the year when we did this. Okay, actually I want to do a normal dot, not a star like that. Okay, that's the property. And the reason this works, or the reason this property exists, is because, let me give you an example here. If I have, I'm just going to make something up, 2, and I raise 2 to the power of 3, and then I raise that to the power of, I don't want to make this too big, 2. Should I do 4? Okay, let's do 4. All right. So what I have on the inside is 2 times 2, let me use the dot, 2 times, copy that so I don't have to do 2 times 2 times 2, and I have that still to the raised to the power of 4. So what I did was I rewrote 2 to the third power, and I'm rewriting that as what that means, 2 times 2 times 2, 3 times, okay? And then I'm going to take that, 2 times 2 times 2, actually I'm going to copy and paste this, and I'm going to, it's going to go off the screen. I'm going to take that 2 times 2 times 2, and 4 times I'm going to multiply that by, like I said, off the screen, but I can always scroll back over. So, okay, just to recap, now that that's typed up, 2 to the third power is the same as 2 times 2 times 2, so I rewrote that. Well, something to the fourth power is the same as that thing times itself 4 times. And as you can see here, we end up with 2 times 2 times 2 times 2 times 2 times 2. Well, there's 12 of them. Okay, 12 2's here. The parentheses could actually be just dropped out because everything here is multiplication now. So you can actually just drop the parentheses out. Actually, maybe I should do that in a new line. Okay, so I'm going to just drop the parentheses out of this for each of these. And I have 12 2's. Parentheses no longer matter. Everything's multiplication, order of operation holds. And as you can see, with 12 2's, that is the same as 2 raised to the 12, right? Which is the same as 2 raised to the 3 times 2. 4, sorry, 3 times 4, that's what I meant. All right, so hopefully that makes sense. That property that I'm using, base to a power is the same as multiplying by the powers. Okay, and that's what I'm using right here. All of that to show you that what I'm using right here, this is a thought bubble, and all of that, I'm going to move it over so it doesn't look like it's part of the example, to show you that 5 raised to the third to the v is 5 3v. Okay, And the whole point of doing that was to get like bases, exactly the same bases, 5 on both sides. Nothing else on either side of the equation, just the base 5 to a power. Well, using this one-to-one property, then I can say that 3v is equal to 1. The exponents are equal. Oh, 1 second. Sorry, before I do that. If I have 5 to no power, that's the same as 5 to the first power. So this is base to a power. It's just we don't show to the power of 1. Well, in this case, we want to see that. We want to put that there because I need to be able to convert it to 1 using the one-to-one property. So we want to use a 1 in that place. So 3v equals 1. Hopefully you understand how I went from 5 to the third to the v to 5 3v, and hopefully you understand how I went from 5 to 5 to the 1. And then 3v equals 1 is v equals 1/3 is the answer. Switch back to the hand. All right, let's do another one. This one we won't be using the one-to-one property. We will only be using the one-to-one property when we are looking at for this section only. We won't be doing it beyond this section unless you want to. There will be some problems that I say, please use the one-to-one property. So you'd have to do this with it. And it would be only when you have problems that you have a log problem that's equal to an unknown. Okay, this property though, the unknown is in the base. So we have 5 is equal to log base v of 32. Okay, again, the first thing you want to do in this case, in a problem like this, is we want to convert this to exponential form. This is in logarithmic form, and it shouldn't be. There's no point in having something in logarithmic form if the base is unknown, because in exponential form, we have base v to the power of 5 is equal to 32. Well, this problem here, base v to the power of 5 equals 32, is a problem we can solve. This is not. So the whole point of logarithms is to put the problem in, an exponential form problem into log so we can solve for an unknown value that we can't solve for, but we can solve for the base in this already because it's not the exponent that's unknown. Logs help us solve for exponents. Okay, so that this is a logarithmic form problem that should not be in logarithmic form is my point. So we convert it to exponential form to solve it. We solve this by taking the fifth root of both sides. The power of 5's opposite is the fifth root. Let me recap fifth roots on your graphing calculator. So if what you cannot do, what's wrong would be to do 5 and then square root. 5 square root is 5 times the square root, okay? 5 second square root is 5 times the square. That's not fifth root. Wrong, okay? What you want to do is in the math button, you have number 5 is an x and then a radical. This is what you want. And then with this radical, you can do any root that's not a square root, and a cube root. You also have a button for cube root, but anything beyond that, you need to use the fifth root for. Or there's other ways to do it, but you'll want to use the fifth root for. But in order to use that button, you need to put the 5 in first. You need to put 5 in first. So because it's a fifth root, I'm putting 5 in. And then I'm going second math. Oh, sorry, not second math, just math. And I'm going down to this option. And you can see how it superscripts the 5, and that's quite different from, and you get 2 as an answer. That's what we want. That's quite different from this, which is the square root of 32 times 5. See how you get different answers? Well, that's because this is not a fifth root, okay? Everybody get that? Okay, that's 5 times the square root. This is a fifth root, which is, by the way, the fifth root is saying what multiplied by itself 5 times gives me 32, and the answer is 2. Okay. The other spot on a logarithmic function, so you can see here we're going through there's 3 parts of a logarithmic function. We have the value, the base, and the part that's in the log. And we just went through each part. And if this is unknown, what do we do? If this is unknown, what do we do? If this is unknown, what do we do? Well, again, this is a logarithmic function where the unknown value um, is better solved when it's not in logarithmic form. That makes sense. When the thing inside the log is unknown, it's better to solve this when it's not in logarithmic form. So let's convert it. 3 to the power of 4 is equal to b. Wow, how much easier is that to solve? 3 to the power of 4 is the same as 9 times 9. You can take 3 times 3 times 3 times 3, and you will get 81. Pretty cool, huh? Let's see, was there anything else I wanted to say about this? If you go back up to this, yeah, let me just recap each of these real quick. Logarithmic form is a way of rewriting an exponential form where you're solving for the exponent. See how that's solving for the exponent. And if you're looking at this log, you're asking yourself, 125 to what power gives me 5? Okay, 125 to what power gives me 5? And the answer is the power of 1/3. 125 raised to the 1/3 power gives me 5. See how that worked out? Which is the same as a cube root, by the way, another rules of exponents. This is saying what to the 5th power gives me 32. 2 to the 5th power gives me 32. Okay? And this one's saying 3 to the 4th power gives me what? 3 to the 4th power gives me what? And that was 81. Okay? Makes sense? All right, so I have a problem here that is a scientific I don't know what I'm trying to say. It's a real life world example, I guess, scientific problem. And I want to talk to you about your calculators. Your calculators, I don't remember if I said this before, have a log button on them right here, okay? And just like in math when we don't show numbers like the square root of something, we just put the radical symbol, we don't put a 2. Well, it would be 2 in the superscript if we were to write something for the square root. Just like a power of 1, we don't write power of 1 every time. Log, if there is no base written, okay, this is important. If you see a log with no base written, it is by default a base 10. Base 10 is the default for log. Okay, and it's actually called a common log. We'll talk about that a little more. But the reason why I'm emphasizing that is because we are able to use our graphing calculators to solve some chemistry problems here, some real world problems. So I hope you're excited. I'm trying to be. No, I am. Chemistry's fine. So, pH levels. Hopefully this jives with what you've been taught. pH levels in chemistry, if you have chemistry. The pH of a substance is the concentration of the hydrogen ions. And, well, here we have the formula, you know. You can leave all the words to the science people. This formula is what matters. pH is equal to log base 10, negative log base 10 of the H+, which is the hydrogen ions. Okay? All right, so here's the example. The pH of carbonated soda is 3. So the pH level of, I guess it's level, of carbonated soda is 3. And I want to find what is the ion concentration, the hydrogen ion concentration. Okay, so I'm going to use this formula. I'm plugging 3 in for the pH, and I'm solving for this. This bracket H plus thing is all just one variable. So pretend like that's just n. This whole thing, including the bracket, just pretend like that's just n. Okay, so I'm plugging 3 in, and I'm solving this for the H plus. And the first thing I do is move the negative over. Why not? And the second thing I do is convert this to, oh, actually you don't need the log button on your calculator. That'll come later because we're not plugging in and solving for this side. We're actually going to convert this to exponential form. So h plus, okay, h plus will be equal to, actually let me do it this way, 10 to the negative power, or to the power of -3 is equal to h plus. So again, this is just like n. It's a messy n, unknown value, or x, or y, or whatever your variable is. And once that's solved, I just need to simplify it, and I am done. There are 0.001 moles of hydrogen ions in 1 liter of soda. Whatever that means. No, that's important. I'm sure in chemistry that's important. So a little rusty with my chemistry right now, though. So I have bookwork for you to do. I'll post the bookwork in Google Classroom, and hopefully this makes sense. Thank you, and good day.